Okay, here we go to finish up this review. We've just got the law of sines and cosines problems to worry about. Okay, so let's look at 25. For a triangle, and maybe we should say this first. Okay, and we've got a triangle here. We'll call it A, B, C, little b, little c, little a. Okay, remember the law of sines connects a side opposite with its angle, and that's equal to the other side opposite its angle, which is equal to the other side opposite its angle. Okay, which we write as the sine of A over A equals sine of B over B equals sine of C over C. Okay, it only works if we have at least one of those connections. Okay, if we don't have a side opposite an angle, we don't have two of those pieces that form that connection, it's not going to work. We can also flip that around and do it A over the sine of A equals B over the sine of B, and so on. Okay, but that's when that works. That's the law of sines, because it has sines. Law of cosine, remembers, connects an angle opposite the side when we don't have one of them, but we have the two sides adjacent to that angle. Okay, that's the law of cosines, and it looks like this. We say that side opposite squared is equal to the adjacent sides squared minus 2 times the adjacent sides times the cosine of that opposite angle. Okay, in both of these cases, law of sines and cosines, you need to have 3 of the 4 pieces of information. Doesn't matter which ones you have, but you need to have 3 of them. Same with sine. We usually only use 2 of the equations at a time, but you need to have 2 of the 4 pieces, 3 of the 4 pieces, I should say. Okay, so let's draw this triangle. We've got triangle TRS. TR is 18, RS is 37, not drawn to scale. Measure of angle T is 143 degrees. We want to find the other 2 angle measures. Okay, so this works with law of sines because I've got that connection. And I've also got a possible connection here. So we can find angle S. Once we know angle S, it's easy to find angle R. So we'd set this up. Now I want to find the angle, so I put the angle on top. I always put the piece on top that I'm looking for. So sine of S over 18 is going to be equal to the sine of 143 degrees over 37. Now to get the sine of S by itself, we just times by 18. So I get the sine of S equals the sine of 143 degrees times 18 over 37. Now because I have got to separate the sine from the angle, that's when we use that inverse, that sine to the -1, okay? And we get our angle, or of our fraction here, to get our degree. Now you can type it in your calculator just like that, or you can figure out this piece first. But I like to make the calculator do all the work, so I actually type it in like this. And I will take a picture to show you how I typed it in as soon as I get it all in. Okay, now I look at my calculator, notice it's in radians, so I use the degree symbol so I don't have to worry about changing it. Except for one problem, I do have to change my calculator settings because I'm going for the degrees. I'm looking for the degrees, not my angle in radians, right? So let's try that again. So here's a picture. Notice first this was radians, RAD, so I had to change it to degrees, because when I did it as radians, even though I used that degree symbol, it spit it out to me in radians, okay? And see how I typed it in just like I saw it. And I used the inverse sine of that fraction, and then it spits it out as 17.02. We'll just call it 17. So 17 degrees is my angle. So if this angle here is 17 degrees. Now I know all three of these add up to 180, so to find angle R, I simply go 143 plus 17, which is 160, subtract that from 180, and we get 20 degrees right there. So angle S 17, angle R 20 degrees. So once we have two angles, it's easy to find the third by just doing that 180 rule. Okay? Alright, let's take a look at 26 and 27. Get that out of the way. Alright, so find measure of angle B. Now notice here, we don't have the side opposite. We also don't have any of these other angles, so we can't use law of sines. Here's a classic law of cosines. Okay, so we're looking for this opposite side. We'll call it A. So I go A squared equals the two adjacent sides, 21 squared plus 30 squared, minus 2 times 21 times 30 times the cosine of 123 degrees. Okay. Now, because I'm looking for this, I know I'm going to have to square root it, so I just square root the whole thing. And what I do is just type it like that into my calculator. Okay. I could do it by hand, especially if I didn't have a calculator that made it easy to do this. But it's much easier to let the calculator do all that heavy lifting, and you get your answer. Once again, we can see that the calculator makes it easy because I just type it in. And so my answer is 45, basically. 45.02 we could say, but 45 is close enough for us right here. Okay, so that's that side, okay, is 45. Now the problem is we're looking for angle B, right? I almost didn't even notice that. Okay, so now that we know what that is, now we can use the law of sines to figure out the rest. So I go the sine of angle B over 21 is equal to the sine of 123 over 45. So sometimes you have to do a combination of both to find something. Okay, times by 21 on both sides. We get the sine of angle B equals sine of 123 times 21 over 45. Then I'm going to do that inverse trick again, and that's going to get my answer for me. Okay, so I'll type that into my calculator really quick. So I go the inverse sine of fraction sine of 123 degrees times 21 over 45. I'm in degree mode, so it'll spit it back out as a degree. So I get the angle, measure of angle B equals 23 degrees. 23.04, but we'll call it 23 for fun. Okay, 27 is going to be the same way. Okay, so I'd go this side little a squared equals 22 squared plus 24 squared minus 2 times 22 times 24 times the cosine of 121 degrees. Okay, then once again I take the square root of that. I just type it into my calculator to make life much easier for me. So I go the square root of 22 squared plus 24 squared minus 2 times 22 times 24 times the cosine of 121. And I type that in, hit enter, and I get my answer of 40.0485. So once again, we'll just say 40. That's close enough. Okay, then I can find the measure of angle B by going the sine of angle B over 22, because that's the connection, equals the sine of 121 over, why did I say degrees? That's 40. You guys got to stop making me look bad. Centimeters. Times by 22, we get sine of B equals the sine of 121 times 22 over 40. Then I take the inverse sine of that whole thing, and that's going to give me the measure of angle B. Okay, so once again, I go the inverse sine of fraction, the sine of 121 degrees times 22 over 40. Hit enter, and we get 28.1279, so 28.1 degrees. We probably could call it 28 degrees, but we'll say that. All right. Now, 28 merely wants us to find AC here, so that makes life a lot easier because all we have to do is the law of cosines. So we go b squared equals, and I'll do this one all the way out for you guys, 27 squared plus 20 squared minus 2 times 27 times 20 times the cosine of 113 degrees. So 27 squared will give us 729. Okay, plus 20 squared is 400. Okay, so plus 400 minus 2 times 27 times 20. And I think I times too many things together. 2 times 27. So that's 1080 cosine of 113 degrees. Then I'd go 729 plus 400. So you can see I'm getting the same thing. It's just much easier to do it using the calculator. Okay, and there's not really much I can do here. Okay, I could figure out what that is. 1080 times the cosine of 113 degrees. That's negative 421.99. So I might as well just from here out do the rest. Okay, could I go 1129 minus that negative 421? Yeah, I could. And then I could take the square root of that. And that would give me 1550.99. Then the square root of that would be 39.38 for AC. Okay, or we could have just done that from the beginning and saved ourselves a lot of trouble and potential for mistakes by just letting the calculator do all that hard number crunching, which is basically what we were doing. And we end up with the same thing, 39.38. Alright, now 29, these ones are not very fun because now we don't have an angle. So we want to find angle A, so our opposite side, very critical that you have the opposite side, right? Because that opposite side is where we start. So we get 9 squared equals 13 squared plus 12 squared minus 2 times 13 times 12 times the cosine of angle A. Now these ones are tough because now we have to simplify a piece at a time. So 9 squared is 81. 13 squared is 169. Yes. 12 squared is 144. There's no quick way to do this one. 13 times 12 times 2 is 312. Cosine of A. Okay, then we combine these two. You're going to run into the problem of trying to, once you get these, that's 313, you may want to subtract the 312 from that. But you can't. You've got to remember that that 312 cosine of A, that's like 312x. Same concept. So I can't deal with it until I divide. Okay? We don't want to divide yet, so I subtract 313. So 81 minus 313, which gives me a negative 232, equals negative 312 cosine of A. Then we divide by negative 312. So we get 232 over 312, because they're positives, equals cosine of A. Now, could I try to reduce this fraction? I could. But at the end of the day, to get this angle, I'm just going to have to take the inverse cosine of that. So I might as well just leave it like that. And I, in my calculator, type the inverse cosine of 232 divided by 312. And I get the measure of angle A, which is 41.96 degrees. Basically 42, but 41.96 degrees. And there's really no shortcut to that one. pretty much have to go that route. Alright, now let's deal with some story problems. So a surveyor is trying to measure the width of a rock formation. He walks to a point far away from the formation and sets up his instruments. So we have this cool rock formation. So he walks away, sets up his instruments. Okay. So he measures, and let's make him walk this way, easier to visualize. So he measures the distance from the left side of the formation is 89 feet. He measures it from the right side of the formation, that's 94 feet. The angle between the two sides is 74. We want to know how wide that is. Okay, classic law of cosines. I don't know this angle or this angle, so I can't use law of sines. So I'm looking for that side. But this is the one we like, because that rock formation squared is equal to our two adjacent sides, 89 squared plus 94 squared minus 2 times 89 times 94 times the cosine of 74 degrees. Then because we're just going to take the square root of that whole thing, we use our handy dandy calculators and we type it in. The square root of 89 squared plus 94 squared minus 2 times 89 times 94 times the cosine of 74 degrees. Hit enter and we get 110.205 feet. There's our measurement, about 110 feet. Okay. Alright, let's take a look at the last two. I'm going to do 30 first. Peter and Elizabeth are standing by a barn. So we've got a barn here. My beautiful, beautiful barn. Elizabeth heads due north of the barn and Peter heads 25 degrees east of north. Okay, so apparently my barn needs to move and needs to look more like a barn right here. Okay, so Elizabeth goes due north. Peter heads 25 degrees east of north. That might be west. I can't remember. When they stop, Peter is 56 meters away from the barn and 63 from Elizabeth. And this is 25 degrees. How far is Elizabeth from the barn? So we want to know this. Elizabeth is right here. Peter is right here. Now, I'm looking at this and trying to see. We can't use the law of sines because we don't have a connection, do we? We don't have that angle, and we don't have that angle. But we can find it because we've got that, don't we? So we can use the law of sines. Okay, so we can figure out that angle, which will allow us to find this angle, which will allow us to find that side. Okay, so that's kind of a crazy one. So I go, the sine of 25 degrees over 63 is equal to the sine, we'll call that angle E for Elizabeth, over 56. Times by 56, we get the sine of angle E, which we're going to have to do the inverse of that whole thing to get what E is. Okay, so once again, in my calculator, I type that in. I do the inverse sine of my fraction, and then I go 56 times the sine of 25 degrees over 63. And that gives me 22.0652. So we'll say for angle E. So we'll say that's 22.07 degrees. Okay, so we now know that that side is 22.07, which means 22.07 plus 25 would get us 47.07. Subtract that from 180. We get 132.93. So this angle right here is 132.93 degrees. So now to get this side, we use the law of sines again. So I go we'll call that little p. Little p over the sine of 132.93 degrees is equal to, we'll use our original, 63 over the sine of 25 degrees. So now I'm doing this one, the other version. So I times by the sine, times by that guy, so the sine of 132.93, and that gives me that distance equals 63 times the sine of 132.93 over the sine of 25. Now I don't need to use the inverse sign because I'm not finding the angle, I'm actually finding the side. So I just write that fraction, 63 times the sine of 132.93 over the sine of 25 degrees, type it into my calculator, hit enter, and we get 109.148. So 109.15 is right there, 109.15 meters. That's how far Elizabeth is away from the barn. Whew, that was a lot of work, wasn't it? Alright, now the last one. Now for this one, I'm going to move this down here so we can draw a picture above. Okay, so it says the sun is currently at a 67 angle, typo, of elevation. So we've got our lovely golden sun here. Okay, it's at a 67 degree angle here. It says a tree is leaning away from the sun at a 5 degree angle and casts an 18-foot shadow. So a tree is leaning at a 5 degree angle here. So the tree's here at a 5 degree angle away from the sun. I'm assuming that's what it means, away from the sun. This would be a 90 degree angle. So if we follow that tree out this way, this angle would be 95 degrees. Okay? And it casts an 18-foot shadow. So the shadow would be right here. And that's 18 feet. How tall is the tree? Okay. So, we've got a triangle right here. We've got that's 18. Oh, wrong way to write the... Yeah, no, that was the right way. We've got that at being an 18. That would be like a right angle. We want to find this side. And we know that this angle is 95, so 180, because the whole thing would be 180. We need to find that angle. So 180 minus 95 would give us 85. So that would be 85 degrees. Okay? So it looks like we don't even need to use the law of sines or cosines here. We could just say that this is the hypotenuse, that's the adjacent, so it would be the cosine of 85 degrees equals the adjacent side over the hypotenuse times both sides by the hypotenuse, then divide by the cosine of 85 degrees, and we get our hypotenuse equals 18 divided by the cosine of 85 degrees. So we then put that into our calculator. And we'd get 206.527. That seems like a really tall tree. 206 feet. I'm not sure if we drew this right. I'm wondering if instead they actually wanted us... I don't know what it means to be leaning away from the sun. It could go either way. Let's think about this if this were the other way. Let's say now our tree is leaning in this direction 5 degrees. So that right there was 5 degrees. So the rest here would be 85 degrees this way. And then would that tree be up to here? And so the shadow would be right here at 18. I guess the whole way would be 18. So if we're doing it this way, then we'd use the law of sines, because we'd have this connected to the tree height, and we can figure out that angle because we'd go 67 plus 85. Subtract that from 180. And we get 28 degrees. So we'd go 18 over the sine of 28 degrees equals what we're looking for, our tree length, over the sine of 67 degrees times by the sine of 67 degrees. And we'd end up typing that into our calculator. So we'd make our fraction, and then we would go the sine of 67 degrees times 18 over the sine of 28 degrees, and we get 35.29, so 35.3 feet. I almost want to say that's more like what they want us to do. Yeah, let's go with that one, because that one's actually using the law of sines, which I believe is what this wants us to do. So, disregard the first one, let's go with this one, and we'll see where we get from that. Alright, there we go.